This video is on sections 7.3 and 7.4, comparing linear to nonlinear functions. Please follow along with your note sheet. So first off, we need to start with what is linear. So in order to see what a linear function looks like, I'd like you to graph all the ordered pairs in the table you're given. So please take a moment and graph them on your coordinate plane. Make sure you're careful. You're going -4, -2, and then -2, -1, 0, 0, +2, +1, and +4, +2. And if you do this accurately, they will form a straight line. Please connect them with a ruler as straight of a line as possible. So one of the key features of a linear function is that it results in a straight line, one continuous straight line. And you'll notice in the word linear is the word line. That's to remind you that a key feature is the graph is a straight line. Now, additionally, there's one other key feature of a linear function. And if you look down here at the graph, we have a constant slope, a constant rate of change. It's rising 1 and running 2. So we have a vertical change of 1 and a horizontal change of 2. If we don't have a graph, we look at the table and we look at the change in y compared to the change in x, because the change in y is the vertical versus the change in x is the horizontal. So to go from -2 to -1, you have to think about what's happening. It's increasing by 1. -2 plus 1 is -1. And if we go from -1 to 0, we're also adding 1. And then 0 to 1 is +1. +1. And so these are consistent. On the left side, we look at our change in x, our change in horizontal. To go from -4 to -2, we're going increase by 2, up 2. And you'll notice that's what happened on the graph. We went up 1 on the y and right 2. And then +2 will get us to 0. +2 to 0 will get us to +2. And so if we look at our change in y, which is 1, over our change in x, we have a slope of 1/2. So if we didn't have this graph to look at to see rise over run, we could find our slope, and that's our rate of change from the table. So the other key feature of a linear function is that it has a constant rate of change. Rate of change is the slope. It's how much it's changing by. So let's look at our linear function. I'd like you to graph the ordered pairs given to you in the table to let you see what a non-linear function would look like. So make sure you go -4, +4, -2, +2, 0, 0, 2, 2, and +4, +4. So if we connect these with straight lines, you'll notice it is not a continuous straight line. It makes a V. So one of the key features of nonlinear, non meaning not, so not linear, not straight, is that the graph is not a straight line. If we don't have a graph to look at, then we would look at the table. So we're looking at our change here. To go from 4 to 2, what has happened? Well, it's 4 minus 2. To go from 2 to 0, it's -2. Please make sure you're writing this on your notes. To go from 0 to 2, though, if we were doing -2, this would become a -2, but we're not. So now it's changed, and it's going +2. To go from 2 to 4, it would also be +2. So we already see here this is not consistent. On the other side, these are all +2s because these values are the same. So if we look at our rate of change, our slope, which is our y change over our x change. Remember, these triangles, delta symbols mean change. So the change in y is -2 over 2 for these two, which is -1 slope or rate of change. But down here we have a +2 over +2, and that's a +1. So nonlinear functions will not have constant rates of change. So the rate of change is not constant. That's a key feature. And when the rate of change is not constant, the graph will not form a straight line. It doesn't have to look like a V, though. It can look like different things, and you'll see some of those. So here's your first one that you need to do. So you're answering which of these are linear and which of these are nonlinear based on what they look like. Here's our second one for you to try. Which of these graphs represent nonlinear or a nonlinear function? And now you're on to the top part of your notes. Is this a linear function? So what I'd like you to do first is fill in the table with the ordered pairs. Now that you have the table done, please graph your ordered pairs so we can see if they form a straight line. 2, 1, 5, 3, 8, 5, and 11, 7. And then please see that they form a straight line, so use a ruler, please. Now I'd like you to draw one of your slope triangles, and then what is the rate of change, or what is the slope for this line? And I would also like you to show how to find the rate of change from the table if you didn't have the graph to look at, because we're looking at the graph so we can see the slope. But if you didn't have the graph, I'd like you to show the rate of change in the table. So what's it changing by in the y? To go from 1 to 3, we have +2. To go from 3 to 5, we have +2, +2. And then on the left side, our horizontal change, our x, is +3, +3, +3. So the rate of change is 2 over 3 because we have y over x. Therefore, this is a linear function for both of the key features. It has a straight line and the rate of change is a constant rate of change. So now we have another one here on the right side of your notes. This time I'd like you to sketch your own table. So please draw a table on your paper and then determine if this is a linear function, and if it is linear, what is the rate of change? Well, we have to make sure that it's a constant rate of change to see if it's linear. So look at the change in y compared to the change in x. You'll notice all of these are the same and all of these are the same. So it is a constant rate of change. And the constant rate of change is y over x, 2 divided by 1. So therefore, yes, it is a linear function because the constant rate of change is 2 over 1. Now, if we don't draw a table, so on this one, I prefer you don't draw a table. I can show you how to do it with just looking at the ordered pairs. So if we look at our change in y, we're going from the y coordinates, the second coordinate, to second coordinate. We go from 0 to 1, that's a +1 change. Then we go from 1 to 4, that's a +3 change. And then we go from 4 to 9, that's a +5 change. So right now we already have concern that this is not going to be constant. But let's double check the x values. We go from 0 to 1, that's +1. We go from 1 to 2, that's +1. We go from 2 to 3, that's +1. So these are constant, but these aren't. Therefore, we have a 1 over 1 rate of change, a 3 over 1 rate of change, and a 5 over 1 rate of change between the points. So it is not linear because the rate of change is not constant. And if we graph this one, just to show you what this nonlinear function looks like, is the points would look like this. And if we draw the lines in between, it curves and it gets steeper and steeper. So this is nonlinear if we were to graph it, but without graphing it, we can tell just by looking at the ordered pairs. So I'd like you to try this one. Looking at it, is the relation a linear function? You could always use the back of your notes, the blank side, if you want to use any scratch paper. So if you look, this is a -3, -3, -3, -3. And on this side, it's going +5, +5, +5. And therefore, what is the rate of change? The rate of change is -3/5, and it is a linear function because this is a constant rate of change. Here's another one for you to try. We have -8, -8, -8, -8. And on this side, they're all +1s. And so, yes, it is linear. And the constant rate of change is -8 because -8 over 1 is just -8. Next one. Is it linear or nonlinear? So going from here to here, we have +1. From here to here, +3, +3, and +2. All of these are +1. So 1 over 1 and 3 over 1 are not a constant rate of change. So this one is a nonlinear. Please try this one. We have +2, +3, +4, +5, and all of these are +1. So once again, not a constant rate of change, so it will not be a straight line, and it is non-linear. Okay, we're back to your notes page. looking at this situation where 20 rabbits are on an island and this population of rabbits triples every 6 months. So therefore, we need to complete this table. So first off, we start with 20 rabbits. So in the population at 0 months, we have 20 rabbits. Then it says every 6 months. So after 6 months have passed, the population triples. So therefore, 20 times 3, it's tripling, is 60. Then we have 6 more months passing. What would be the result after we have 12 months have passed? What number goes here? Well, 60 times 3 is 180. So we're at 180 rabbits. And then we're going to go to 18 months. So we have 12 plus 6 more. And then 180 times 3 is 540. So that's how many would be on the island after 18 months is 540 rabbits. So the next question is, does it represent a linear or nonlinear function? So going from here to here, we have plus 6, plus 6, plus 6. But down here, we have plus 40, plus 120, and plus 360. So linear or nonlinear? This is nonlinear because this is not a constant rate of change. It is increasing more and more every 6 months. And then last but not least, when would the population reach 14,580? So what you want to do is you want to continue your table to figure this out. So continue the pattern. So we are at 18. 18 plus 6 more months would be 24 months. 540 times 3 would give us 1,620. So we're continuing the table down here. So how many months would be after the 24? 24 plus 6 more, we have 30 months. 1,620 times 3, 4,860. 6 more months pass. We triple this population and we reach our 14,580. So it's going to take 36 months or 3 years to reach a population of 14,580. Next problem has to do with scuba diving. What happens when someone's underwater is that, or as they continue to go deeper underwater, the water pressure increases. So the table here is showing what is happening. So we have at 10 feet of depth, a 4.4 pound per square inch. So it feels like, well, and it is 4.4 pounds of pressure for every 1 square inch on the human body. So we're looking at, is this function linear or nonlinear? So think about, how are you going to determine, is it linear or nonlinear? Well, we have to look, does it have a constant rate of change? So from 4.4 to 8.8, 8.8 minus 4.4 is plus 4.4. 13.2 minus 8.8 is plus 4.4. So we're figuring out that each of these is having 4.4 more pounds of pressure added for every 10 feet of depth, because each of these are changing by 10. Therefore, it is linear because these are constant. And it says, if it is, what's the rate of change and what does it represent? So in this case, it's 4.4 over 10. It's always output over input, y over x. So we have 4.4 pounds per square inch per every 10 feet of depth. So it's increasing 4.4 pounds per square inch for every 10 feet of depth. Now, if you divide 4.4 by 10, we could also find out that this is 0.44 or 44 hundredths of a pound per square inch for every 1 foot of depth. So either one of these would be okay. And then it says, find the water pressure on the diver at a depth of 60 feet. So we're going to continue the table. If we go 10 more, that's 50. Then that means we're going to go 4.4 more on this side. And then we have to go 10 more feet to get to 60 plus 4.4 more, 26.4. So we have 26.4 pounds per square inch as the water pressure at 60 feet. Last one's not on the notes page, but I do want to answer this. This is showing the population of a species of brown bat, and it's asking, is this relationship linear or nonlinear? So I want you to look at the table and think about, is it linear or nonlinear, and how would you explain that? So the population on the right here, from 19,900 to 13,000, is decreasing 6,900. And then we look from here to here, we already know there's an issue because it's increased. So here, this is not a constant rate of change, even though it's increasing 2 years plus 2 years, the numbers here are not constant. So this would be a graph that goes up and down. So the slope is changing, and therefore it is nonlinear because it does not have a constant rate of change.